Hi everyone. So today we're going to carry on with integration by parts. So we've got a few more problems to go through. Just before the lecture, I got a request to go through questions 3 and 5 from the homework. So we're going to do those first, and then we're going to get onto the planned problems. Okay, so let's just start off with homework problem 3. Okay, so just before we start with this one, we're not going to have a formative quiz or summative quiz on integration by parts because that is supposed to be next week, but we've got the test instead. So it's very important that you go through these homework problems and tutorial problems as practice. Okay, so you're not going to get a practice quiz like we have with volumes. Okay, so let's go through number 3. So we're trying to find the integral of x squared plus 2x cos x dx. Okay, so like we did before, we need to find which part of this integrand is easier to differentiate and which part is easier to integrate. Now we see that this first term in the product is a polynomial. Polynomials, when you differentiate them, they get simpler. So the idea here is to let the quadratic polynomial at the beginning, we let that be u. So u is equal to x squared plus 2x. So then that leaves us with dv being equal to cos x dx. Okay, so we've got those two. Now we need to find du and v. So we differentiate the first one. That's going to give us 2x plus 2 dx. And then if we integrate this second term, we're going to have v is equal to sine x. Okay, so we've got du and v, which is what we need because we need to substitute these 4 things into our formula. So the integral of u dv is equal to uv minus the integral v du. Okay, so we just plug in everything. So the integral of u dv, that's what we're trying to find. That is x squared plus 2x cos x dx. Okay, that's what we're trying to figure out, is equal to u times v. So that's x squared plus 2x sine x minus the integral of v du. So that's going to be 2x plus 2 sine x dx. Okay, so it's definitely simpler than what we had before. However, if you notice on the extreme right, we've got this. Okay, so this is very similar to what we started with. Again, we've got a product of 2 things. So we need to do integration by parts again. Okay, so sometimes you have to do it more than once. Okay, so let's do it again. So now we're trying to find the integral of 2x plus 2 sine x dx. Okay, so let's do integration by parts again on this term here. So like we did before, u is going to be the first term, dv is going to be the second part. Okay, we've got u and dv, but we need du and v. So we differentiate the first one. So that's going to give us 2 dx. We integrate the second, and we get v is equal to the integral of sine, that's minus cosine. Okay, then we substitute it into the formula. So the integral u dv is equal to uv minus the integral v du. Okay, then we just substitute in. So u dv, that's what we started with. That was 2x plus 2 sine x dx. Okay, that's what we're trying to find. U times v, that's going to be minus 2x plus 2 cos x minus the integral of v du. That's going to be minus 2 cos x dx. So that's going to be minus 2x plus 2 cos x. And then plus 2 times the integral of cos x dx. Okay, but we know what that is. That's just going to be sine. So this is going to be minus 2x plus 2 cos x plus 2 sine x. Okay, so all of this is our answer for that part that was missing. That big box in yellow, that integral is this part over here. So we just need to add this. So we're taking, zoom out here. So we're taking this and we substituting it back. Okay, and then that will give us our final answer. So the integral of x squared plus 2x cos x dx is equal to that part we had before, x squared plus 2x times sine x. And then we need to subtract the integral that we just worked out. So minus, and then the stuff we just worked out was minus 2x plus 2 cos x plus 2 sine x. And now we can add the plus c because it's an indefinite integral. So this gives us x squared plus 2x sine x. The minus and the minus make a plus. So we have plus 2x plus 2 cos x, and then minus 2 sine x, and then plus c. Okay, and then this is our final answer. So it's the same thing that we did before, just in this case, the resulting integral from the first integration by parts needed integration by parts again. Okay, so that's the only difference here. So we just do it twice. Okay, then we substitute back. Okay, what we found. And then that gives us our final answer once we add everything together. Okay, any questions on this? Okay, let's take a look at homework problem number 5. Okay, so this was the integral of tan inverse x dx. Okay, so in the lecture, I gave you a little hint what we needed to do. We're going to insert an imaginary 1. So we're going to have tan inverse of x times 1. That doesn't change anything, dx. Okay, so as the hint said, we're going to let u be equal to tan inverse. And we're going to let dv be equal to the remainder, so 1 dx. Okay, the derivative of tan inverse, that's going to be 1 over 1 plus x squared dx. And then we need to integrate this to find v. So v is just going to be x. Okay, so now that we found those two, we just substitute into the formula. So the integral of u dv is equal to uv minus the integral v du. Okay, we substitute in. U dv is just what we started with, tan inverse of x dx. U times v, is going to be x times the tan inverse of x minus the integral of v du. That's going to be x over 1 plus x squared dx. And this over here is just a u substitution problem. So u substitution with u being equal to 1 plus x squared. Okay, we did something very similar to this before. Okay, so you just do your u substitution there, and then your final answer is x tan inverse of x minus 1/2 the natural log of 1 plus x squared. Okay, and then we can add our plus c. Okay, so then that's our integration by parts done. Okay, any questions on this one?
Yes, could you please explain?
Got a question here. Can you explain in detail on the part where you did 1 over 1 plus? This part over here, the derivative of tan inverse. Yes. Okay, so let me actually just open the notes here so you can see, because you should have done this last year. Let me just find it here. Okay, can you see the notes here?
Yes, sir.
You can see. Okay, let me just find where it is. Derivative of inverses. It's at page 33. Okay, so over here, derivative of inverses. Just take a look at these notes here, the Math196 notes extra that I typed out. It goes through all of the steps that you need to do to find the derivative of inverse functions. So here I do the example of finding the derivative of sine inverse. Okay, it goes through all the steps here. And then there's some exercises here on finding the other derivatives. Okay, so you just need to follow these steps over here to find it. Okay, so on the group, I'll just make a little reminder of where to find this here. Okay, are there any other questions on this? Okay, so let's carry on with what we were supposed to do for this lecture. Okay, so these were the two homework problems that someone asked me to go through. And then after this lecture, I will post more homework problems. You know, same rules as before. If you submit a correct solution, you get your bonus marks. Okay, so let's start off with today's problems now. So problem number 1, we're trying to find the integral of e to the x sine x dx. Okay, and this is an integration by parts question because we have a product of two things. Okay, so one of these things we need to differentiate, the other one we need to integrate. Now, trying to decide between e to the x and sine of x, you'll see that we can actually do it both ways. E to the x is easy to differentiate and integrate. Sine of x, that is easy to differentiate and integrate. So it actually doesn't matter which one we pick. So let's just say u is equal to e to the x and dv is equal to sine x dx. Okay, you can swap them around, you will get exactly the same answer. So maybe you want to try that as an extra homework thing. Try to do it with these swapped, see if you get the same result. So du is going to be e to the x dx. We need to integrate this, and v is equal to minus cos x. Okay, now we use the formula. Integral u dv is equal to uv minus the integral v du. So we have the integral e to the x sine x dx, that's what we want to find, is equal to minus e to the x cos x minus the integral of e to the x minus cos x dx. Okay, so we've got a minus and a minus. We can turn that into a plus. So we have minus e to the x cos x plus the integral of e to the x cos x dx. Okay, so now we have a very similar problem to what we had last time. We've got this term over here where we need to do integration by parts a second time. Okay, so let's just make a little note. We need to do integration by parts again. Okay, because of this term that I put in a box. Okay, so let's do that. So we need to find the integral of e to the x cos x dx. Okay, so same as before, we need to let u be something and dv be the other something. Okay, so it doesn't matter which way we do it, because either way we're going to get the same thing. So let's say u is equal to e to the x, and dv is equal to cos x dx. Okay, so same as always, we need to differentiate u, we need to integrate dv. So du is going to be e to the x dx. Integrate. V is going to be sine x. Okay, so now that we've got these two, we can then substitute into the formula one more time. So integral u dv is equal to uv minus the integral v du. So this gives us the integral of e to the x cos x dx. That's what we want to find. That's this over here. We're trying to find that. Is equal to u times v. So that's going to be e to the x sine x. And then we're going to have minus the integral of e to the x sine x dx. Okay, so same as before, we've got this. We then substitute back because we're trying to find that thing in yellow. We've worked it out using integration by parts. We need to substitute it back. Therefore, the integral of e to the x sine x dx is equal to, what working did we have before? Minus e to the x cos x. And then we had to add this integral, but that integral is this over here. So we're going to add that. So it's going to be plus e to the x sine x minus the integral e to the x sine x dx. Now, you might think to yourself, this is a problem because over here, we've got another integration by parts to do. So you might think, oh, we're going to have to do this a third time and a fourth time and so on. But we don't need to, because look at the integral we're trying to work out. We've got that on the left-hand side, and we've got this on the right-hand side, but with a minus sign. So what we can do is take this term on the right-hand side and take it over to the other side. So we end up with 2 times the integral that we want is equal to minus e to the x cos x plus e to the x sine x. Okay, so we get 2 times the integral we want. So we can just divide both sides by 2 now. So we're going to have the integral e to the x sine x dx is now half of the right-hand side. And don't forget your plus c. Okay, so this is just another little trick that we can use for integration by parts. So we did integration by parts once, and we've got this extra term that we need to evaluate. We did integration by parts again, and we saw that when we do integration by parts again, we get our original integral back. So this was the original integral. Okay, so we got the original integral back. So this is something like, if I just write it on the side, our integral, let's call it r, is equal to minus e to the x cos x plus e to the x sine x, and then minus I again. Yeah, that's what we have there. So all we need to do is solve this equation for r. And that's exactly what we're doing over here. Yeah, and then that gives us our final answer there. Okay, so this is another trick you can use with integration by parts. Sometimes if you do it once and then once again, we get back the original integral, but then we can just solve for it as if it were this variable r. Okay, so that's what we're doing over here. Okay, any questions on this? Okay, and just as a big hint for test 2 coming up, you will definitely get a question like this. Okay, so for those of you here that attending the Zoom lectures, you got a nice hint there for test 2. Okay, definitely something like this will come up. Okay, someone's asking here for me to re-explain. Okay, so let's just scroll back up to the top here. Okay, so this was our original integral that we want to find. The integral of e to the x sine x dx. Okay, so as always, we pick something to be u and we pick something to be dv. Okay, so we do that. We then find du and v. Okay, that's what we need to then substitute into our formula. Right, that's our integration by parts formula. We do that, right, and we end up with this integral to do. Now, this integral requires us to do integration by parts a second time. Okay, because it's a product of two things. We have to do integration by parts again. So we do that. We do integration by parts again, and we see that over here, the original integral comes back. Okay, so we did integration by parts 2 times, and we get back the original integral. So if we substitute this back into our expression, so we substitute it back into the first integral, then we get something like this. We get our integral, r, is equal to minus e to the x cos x plus e to the x sine x minus r, where I is the integral we're trying to solve. So we take I over to the other side, and we get 2r is equal to the stuff on the right-hand side. We divide both sides by 2, and we get what we wanted. Okay, so it's just a little trick that we can use. Whenever we get back the original integral, when we're doing integration by parts, we can take it over to the other side and then solve for it as if it were just a variable like this. Okay, cool. Okay, just check the chat again. Someone wants to do another example. Yeah, we've got plenty more to do. And someone said understood. Okay. Okay, so just keep in mind that you can use this trick. Okay, and again, this type of question will come out in test 2. Okay, so a little hint for those that are attending the Zoom lectures or watching the videos. Okay, we are on example 2. Okay, so number 2, we have the integral of x to the 4 natural log of x dx. Okay, so same thing as before. We need to find which thing is going to be u, which thing is going to be dv. Now, if we look between the two, we see that if we let u be the natural log of x, then the derivative becomes simpler. So we start off with a complicated function, natural log of x. If we differentiate it, we're going to get 1 over x, okay, which is much simpler than what we started with. So that is the big hint to tell us that u should be the natural log of x. Okay, that's the kind of thinking that you should be going through when looking at these questions. Which part gives us something easier when we differentiate, and which part gives us something easy to integrate? In this case, the natural log of x is much easier to differentiate, so that's what we let u be. Okay. And then dv is x to the 4 dx. Okay, because we don't have a choice with that. Once we've chosen u, then the rest of it is going to be dv. Okay, so du is going to be 1 over x dx. And then we integrate and integrate. V is going to be 1/5 x to the 5. Okay, so we've got everything we need to then substitute into the formula. Remember what that was. Integral u dv is equal to uv minus the integral v du. Okay, I'm sure everyone has memorized it by now because we've said it so many times. Okay, so the integral u dv is x to the 4 natural log of x dx. That's what we started with. U times v is going to be 1/5 x to the 5 natural log of x minus the integral v du is going to be minus 1/5 x to the 5 times 1 over x dx. Okay, looking a bit messy, but we can simplify that. This is going to be 1/5 x to the 5 natural log of x minus 1/5 the integral x to the 5 times 1 over x. We're just taking 1 away from the exponent. So this is the same thing as x to the 4. Okay, because remember, this is just x to the minus 1. Okay, so we're subtracting 1 from the exponent. Dx. Okay, that's easy enough to do. We're going to get 1/5 x to the 5 natural log of x minus 1/5 times 1/5 x to the 5 plus c. And then 1/5 times 1/5, that's 1 over 25. So we get 1 over 5 x to the 5 natural log of x minus 1 over 25 x to the 5. And then don't forget your plus c. Okay, so in this case, we didn't need to do integration by parts a second time. Okay, so once was enough for this. Okay, just by the way, the questions where you have to do integration by parts twice is like up to double the amount of marks of a single integration by parts. Okay, so just check where, with the marking scheme on the side, if it's like double what a normal question is, that gives you a hint that you should be doing it twice. Okay, but just keep an eye out for this term over here. Sometimes you have to do it twice. This case, we only had to do it once. Okay, but just be careful of that. Okay, let's just go through some of the homework problems for today. We're going to have 2 problems, and they are going to be 2 bonus marks each. Let's go with that. Okay, and I'm going to give you a little hint as well, just to help you out. So, homework problems. Okay, just before I get through the homework problems here, are there any questions about doing integration by parts twice? Okay, so we had 2 examples of doing it twice. Is there anyone not comfortable with that, or are you okay with that? Okay, so it's not too bad. If you can do it once, then doing it a second time is not too much more of a problem. Okay, so the first question here, this is worth one mark. So we have the integral x squared e to the x dx. Okay, so that's 1 bonus mark. Integral of x cos x. Oh, sorry. Let's make it a bit more difficult. E to the x cos 2x dx. That's 1 bonus mark because we've done something similar to this. And just put a little star there because that's something like what I'm going to put in the test, something like that. Maybe I'm going to change the 2 to a 3 or something like that. Okay, third question. Okay, so this is where the extra marks come in. The integral e to the square root of x dx. This is going to be worth 2 marks. And the last question here, the integral of sine natural log of x dx. This is also worth 2 bonus marks. And then the hint for these last 2 is do a u substitution first. So that is your hint. Okay, so that's your hint for these 2 over here. So first one, that is standard integration by parts. Second one, standard integration by parts. Very similar to the first problem we went through. Question 3 and 4, do a u substitution first, and then you will see that you can do standard integration by parts. Okay, but you have to do this u sub first. Okay. And then just another little bit of advice for test 2. I'm planning on putting in a bonus question. So if you do mess up with one of the smaller questions, then you can use that bonus question to boost your marks. You know, so it's just an extra marks if you are able to do it. To say it another way, the test will be out of 50, for example, but then I will only take 45. Okay, so maybe you get 50 out of 50, and then you've got above 100%, just as an example there. Okay, but then that bonus question will be something like this. Okay, something like these 2 over here, where you have to do a little bit extra. Okay, but then that's like 5 extra marks for your test, something like that. Okay, are there any questions about these homework problems? Okay, so then these will count towards not, just think, yeah, this formative quiz that's coming up tomorrow, these will count towards that. So then you can boost your marks with that. Okay, and then please remember the following week, Wednesday, 6th of April, you got your test 2. That will be everything from area between curves up to integration by parts, which we're finishing off on Thursday. And then the last very small section on the average value of a function. We're going to do that on Friday. Okay, so all of that is coming up in test 2. Okay, and it will be out of 45 marks, but then, like I said, you have that little bonus bit for 5 marks. Okay, so attempt it if you want to, you don't have to if you don't want to. Okay, any questions with regards to the test coming up?
What is the scope for tomorrow's formative quiz?
Okay, let me just put on a new page here. So tomorrow's formative quiz. Okay, so question 1 is on the disk method for finding volumes. That's out of 5. Question 2, that's on the washer method. Sorry, washer method, that's out of 5. And then question 3, that is on the shell method. That is also out of 5. So total 15 marks. Okay, so 3 questions, 1 hour to complete it. Okay, and it's in the form of a multiple choice quiz on Learn 2022. So you don't have to submit anything, just choose the right answer there. Okay, so just 3 questions to go through, and then you have an hour to complete it. The quiz will be open from 10:30 to 12 as usual, and then you have an hour from when you start your attempt. Okay, same as always. Okay, any other questions? Okay, so I will post these homework problems on the WhatsApp group. You can have a look there. The closing time for submission will be 5 o'clock as usual. Got a question here. For all of yesterday's problems. Sure, I can rewrite the solutions, but everyone that I said did the solutions correct, those solutions are fine. But I will post what I wrote as well. Okay, and then I will see you tomorrow in the tutorial sessions. Okay, so remember there's the group A and B that you can attend. And then 10:30, you start your quiz. Okay, bye everyone, and good luck with the homework problems. I'll see you tomorrow.